March 1945. The eastern bank of the Rhine River lies in silence, broken only by the distant echo of artillery and the murmur of men moving in the mist. The air is cold and heavy, soaked with the metallic scent of river water and cordite. Captain Klaus Bergmann raises his binoculars, the glass chilled against his face. Across the wide gray water, he watches the Americans. They are moving fast, too fast. Only 12 minutes have passed since they began assembling something on the western shore. 6 men per section. No cranes, no machinery, just human muscle and steel panels. Bergmann squints through the fog. The panels look identical, precisely manufactured, all of them gleaming under the overcast light. He lowers the binoculars for a moment and exhales. His training tells him what he's seeing is impossible. Klaus Bergmann isn't just a soldier. Before the war, he was a civil engineer. He had spent years designing bridges for peacetime Germany, railway crossings, road spans, heavy-duty viaducts. When the Wehrmacht recalled him in 1943, they didn't send him to the front with a rifle. They assigned him to the 12th Engineer Battalion, a unit that specialized in tactical construction, field fortifications, demolitions, and most importantly, bridges. He learned quickly that war did not care for beauty or permanence. It only cared for function. In combat, a bridge doesn't need to stand for decades. It only needs to survive long enough for an army to cross. 3 days, perhaps a week. After that, the front moves on, and the structure becomes irrelevant, abandoned or destroyed to slow the next enemy advance. Even temporary bridges, though, still follow the same unyielding laws of physics. Load calculations, tension, compression, the limits of steel and wood under stress. You can't cheat gravity. You can only work around it. In the past 2 years, Bergmann had built 17 bridges under fire, wooden trestles across freezing rivers in Russia, steel girders over canals in France, pontoon crossings during the Ardennes offensive. Each project took days, sometimes weeks. He had also destroyed 23. Bridges were power in this war. A standing bridge meant mobility. A destroyed one meant delay. Every collapse bought time for regrouping, for counterattacks, for survival. And now, that very principle, the idea that destruction buys time, is being shattered before his eyes. Operation Plunder had begun 24 hours earlier, the largest Allied river crossing since D-Day. Under the cover of darkness, British and American forces had crossed the Rhine north of Wesel. 20,000 men had established bridgeheads on the eastern bank. Another 100,000 waited to pour across behind them. But to move their tanks, their artillery, their endless convoys of supply trucks, they needed bridges, heavy ones. German intelligence had been confident. Every Rhine bridge had been demolished during the retreat. Every major crossing from Remagen to Karlsruhe was gone. To rebuild them, the Allies would need engineers, equipment, time, at least 3 weeks, according to German estimates. That was the cornerstone of the defensive plan: 3 weeks to reorganize, reposition, and prepare for the final stand. But now, as Bergmann stares through his binoculars, the math doesn't hold. 30 minutes have passed. 4 modules are already in place. He opens his field notebook, his pencil scratching rapidly. Modular panels, steel, approximately 3 meters long, perhaps 1.5 meters high. 6-man teams, no cranes, no foundation work, direct ground assembly. It shouldn't be possible, and yet it's happening. Another half hour, 5 modules. His mind races. If they continue at this pace, the Americans will complete the bridge in under 6 hours. Unthinkable. But the bridge keeps growing. 2 hours later, Bergman hasn't moved. He hasn't eaten. He hasn't even taken his eyes off the construction site. The repetition is hypnotic. Panel after panel, connected with mechanical precision. Each piece fits perfectly into the next. No adjustments, no hesitation. Every hole aligns, every pin slides in with a hammer's hiss. He begins to understand. Each panel is identical, 3 meters long, 1.5 meters tall, weighing roughly 260 kilograms. 8 pinholes per panel, 4 on each end, perfectly aligned. 6 soldiers lift it, position it, lock it into place in less than 15 minutes. He calculates again. 60 meters divided by 3 meters per panel, 20 panels. 15 minutes per panel equals 5 hours total. Add setup time, anchoring, testing, perhaps 6 hours at most. He looks closer. The Americans aren't using concrete foundations. No curing time, no excavation, none of the methods every German engineer takes for granted. Instead, they're laying heavy steel base plates directly onto the earth, level, secure, and fast. The vertical supports aren't even special parts. They're the same panels rotated upright, connected at the same points. Lateral bracing? The same panels again, angled, pinned, tightened. It dawns on him that the entire structure, every horizontal beam, every vertical support, every reinforcement, is built from the same standardized component. One design, one system, infinite flexibility. Bergman lowers his binoculars and stares at the ground. The brilliance is painful to admit. His bridges required teams of craftsmen, welders, fitters, foremen, men who could read pages of technical drawings. Each bridge he built was unique, tailored for that location. But the Americans have stripped all of that away. No custom fabrication, no complex blueprints, just repetition and precision. They don't need engineers. They need soldiers who can follow a procedure. Train a man to assemble one section correctly, and he can build an entire bridge. Multiply that by dozens of teams, and you have an army of builders who can turn rivers into roads overnight. 4 hours pass. The bridge is halfway across. The panels fit like parts of a machine. Each team moves in rhythm, unspoken coordination. No arguments, no confusion, just methodical progress. By the 6th hour, the final pin is hammered into place. Bergman notes the time. 8 hours and 17 minutes since the first section touched the ground. The Americans don't celebrate. There's no cheering, no pause. Immediately, they begin testing. A jeep crosses first, lightweight, cautious. Then a supply truck, 2 tons, loaded with crates. No movement, no sag. Next, a 6-ton GMC truck, still stable. Then the real test, a Sherman tank, 32 tons of armor and steel. It grinds forward, treads clattering on the panels. Bergman holds his breath. The bridge holds, perfectly. No visible flex, no deflection beyond a few centimeters. The tank rolls off the far bank, and another follows, then another. Within minutes, a convoy of vehicles is flowing east. He watches for another hour, dozens of vehicles, heavy and light, one after another. The structure absorbs it all without complaint. It's not a temporary bridge, he realizes. It's a highway. Then, movement catches his eye. 3 kilometers downstream, another American team assembling another bridge. Same panels, same rhythm, same speed. He shifts his binoculars and watches. They're 2 hours behind the first, but they're catching up. One system replicated endlessly. In that moment, Bergman understands what he's witnessing isn't engineering, it's industry. The Americans aren't just building a bridge, they're mass-producing victory. He opens his notebook again. If one team can build a 60-meter bridge in 8 hours, and there are 10 teams working along this sector, that's 10 bridges in a day, 10 crossings in 24 hours. He thinks of the German retreat. 23 bridges destroyed across the Rhine, each one an operation requiring weeks of preparation and tons of explosives. The Americans can replace them all in 3 days. 3 days. By nightfall, Bergman returns to headquarters. The operations room glows under yellow lamps, maps covering every wall. Red X's mark destroyed bridges. Blue lines mark defensive positions. He delivers his report. 2 bridges completed in 1 day, 8 hours each. 40-ton capacity, prefabricated modular system. The colonel takes notes, pauses, and asks the only question that matters. Can we destroy them? Bergman hesitates. Yes, Herr Oberst, but they'll rebuild them in 8 hours. Silence. The colonel stares at the map, the red marks that once represented victory. Every bridge blown up, every delay painstakingly achieved. All of it meaningless now. How many teams? The colonel asks quietly. At least 2 in my sector. Bergman answers. Reports suggest similar activity along the entire front. The colonel does the math. 30 bridges in a day. The entire defensive plan, built on weeks of delay, collapses in seconds. The truth is brutal. The war of engineers has become a war of factories. Germany cannot copy this system, not because the design is secret, but because the nation no longer has the means. The factories that could have produced such panels lie in ruins. Steel production has cratered under Allied bombing. The Ruhr, once the beating industrial heart of Europe, is crippled. And training? Impossible. German recruits get 6 weeks of basic instruction before being thrown to the front. There is no time to turn them into bridge builders. Bergman finishes his report at 2 a.m. His lamp flickers in the darkened command post. The words come slowly now, each one weighted with the realization of defeat. The Bailey Bridge represents a transformation in military engineering. It removes the need for specialized skill at the front. It turns soldiers into engineers through repetition. It renders our strategy of destruction obsolete. He signs it, knowing it will move up the chain of command too slowly to matter. He leans back and thinks of Donald Bailey, the British engineer who designed the bridge. Bailey probably never heard artillery fire, never saw men die waiting for a crossing, but he understood something no general on either side could deny. In modern war, speed is power. The Bailey Bridge wasn't the strongest or the most beautiful bridge ever built, but it was the fastest, the most adaptable, and the most industrial, and that made it the most decisive. By war's end, Allied forces would build more than 3,000 Bailey bridges across Europe, Africa, and Asia, over 1,000 kilometers of steel. Many still stand today, carrying civilian traffic where soldiers once marched. What Bergman witnessed that March day wasn't just an engineering feat. It was the turning point of industrial warfare. Wars are no longer won by courage or by cunning. They are won by production, by the ability to turn design into dominance faster than the enemy can react. And as the Rhine crossings proved, industry, cold, methodical, and relentless, always wins. The Rhine lies quiet now. The echo of tank treads fades into the distance, replaced by the hum of trucks and the creak of steel. The bridge, once a symbol of impossibility, stands firm, carrying an endless stream of Allied power eastward into the heart of Germany. Klaus Bergman, lowers his binoculars one last time. Across the river, the American flag flutters in the mist. The war, he realizes, is already lost, not because of courage or bravery, not because of one decisive battle, but because of the quiet, relentless power of production. He watches the bridge disappear into the fog, a machine of steel and symmetry, and he understands this is the future of war, not chaos, not art, not improvisation, industry, calculation, repetition. The Bailey Bridge is more than steel. It's the physical form of an idea that victory belongs to those who can build faster than destruction can keep up. As dawn breaks over the Rhine, Bergman writes his final line in his notebook. War is no longer fought with guns and men. It's fought with factories and minds. And with that, he closes it forever. The Bailey Bridge didn't just help the Allies cross rivers. It helped them cross the final threshold of World War II. It became a symbol of innovation, efficiency, and the industrial might that defined the modern battlefield. From the icy rivers of Europe to the jungles of Burma, the Bailey Bridge carried the weight of victory. It wasn't just a bridge. It was a revolution in how wars were won. If you've made it this far, you've just witnessed one of the most overlooked engineering miracles of World War II. But there's more. The battles of the Rhine were just one part of the story. Next, we'll take you inside the skies above Berlin, where the air war pushed technology, strategy, and human endurance to their breaking point. Make sure to subscribe, turn on notifications, and continue your journey through history with our next documentary. And if you want to see how these bridges and tanks changed the outcome of the entire war, click on the videos appearing right now on your screen. This was the story of the Bailey Bridge, the bridge that built victory.